Geo Metro Ninjas. Today we are going to talk about partitioning a segment. So partitioning a line segment means we're going to divide our line segment into a given ratio. Ratios can be represented in sylogy form. Okay, so A colon B, or in word form, A to B. Right? So we should remember a little bit. Okay? In English, we use that colon to compare two things. In mathematics, it's part of a ratio. So in our two numbers, the ratio is going to add together to equal the number of pieces. The biggest thing with our ratio is the naming, the way it is titled, matters. Okay? So we look at number one. Given the directed line segment A to B, so that's the full length, determine point P so that it divides the segment of a ratio 1 to 3. So right now, point P does not exist. We are going to put point P on our diagram that takes our ratio and creates a segment of 1 to 3. So we want one segment, and then we want 3. 1, 2, 3. So point P is going to fall right there. So we have our one segment, and then we have our segment of 3. So we're simply creating a ratio. Not too bad. Color in, we get to have some fun. Okay, so what if we say the other direction? So we look at our next diagram. So given the line directed of segment BD. So the last one, we went from A across to B. This one, we're going to go the other direction, B to D. So when we're using our titles, the order of things matters. Okay, again, we're going to determine point P so that we divide our segment to a ratio of 3 to 1. So we want our first segment to be cut into thirds. So 1, 2, 3. So that's going to be our first 3. And then, of course, that leaves us with our last guy hanging out there. Go ahead, buddy.
No.
You don't have a question? You can ask questions. Questions are good.
Wait, why did you put it on that side? It's from B to D, but this one's from A to B.
Right.
It's still on the same side.
Excellent question. So we look at the two, right? So the first, they're both being cut by a ratio of 3 to 1 or 1 to 3. The first one says A to B, so our one segment comes first before we get to our 3 segments. This one, the B comes first, so now we're going the other direction. So that's why the 3 is going to come first, because it comes first in our analogy.
Oh.
It's cut the exact same, right? When you look at the two diagrams, they look the exact same. But it's the way that the order is being explained to us. Correct, because if they would have called this segment DB, right, because then it would have been, now we're taking our 3 segments from the bottom and leaving our single segment on the right. So it's the order that they're telling us.
So they said 1 to 3.
If they said 1 to 3, it would have been swift. Okay. So FG, are we going left to right or right to left? Left to right. We're going to the right. To the right, to the right. So we want to determine point P so that we're dividing it into a segment of 3 to 5. Okay, so we're going to knock off our 3 segment first. So there's our 3. And then that should leave us 5 pieces on the right side. Maybe if I do a different color, that'll help. So if we got 5 gold pieces, 3 navy pieces, we know to put P right there. All right, KJ, we going left to right or right to left?
Right.
Right to left on your radio dial, right? Point P, so that divides it into a segment of 4 to 1. So we start at K, and we're cutting it into 4 segments right there to be our first segment. So that's where P's got to go. How do we know which? I mean, they're technically all filled in. I'm just coloring them in just for the sake of like the visual, but they're not really existing. It's this is 4 segments. This is just a singular segment. You don't have to color any of them in if you don't want to. You don't even have to do the little boxes on top if you don't. If you just want to count circles and that's how you get there, that's fine. Okay, so now they did provide us with point P. So segment DE, so order matters. So we're going to the right. The ratio to the direct line of P. So how many segments are from D to P? How many segments are from P to E?
One segment from P to E.
1, 2, 3. So that's 3 and then 1. So our ratio is 3 to 1. Or we could have said 3 to 1. And the same thing goes for the one on the right. We're going G to F, so we're going right to left. How many segments before we get to P? 3. And then after P? 5. So our ratio from G to F is 3 to 5. Or you can write it in word form, 3 to 5. What if I flip it? What if I ask the ratio from F to G? How would that have changed it?
5 to 3.
Now it would become 5 to 3. So the order that this is written is going to matter. Is there any questions before we move on to doing this algebraically? Algebraically. Because this is math class after all, and we love algebra. Debatable. I love algebra. What? All right, here we go. This beautiful formula.
Oh, wow.
You have to memorize any of your formulas?
X1 plus
No. Okay. So this beautiful formula is simply creating our point. Just like the midpoint formula, this is going to create the point for us. So we've got to identify a couple of pieces. Looking at our formula, what variables do we need?
X1.
We need X1.
X2.
Okay, there's an X2.
Y1.
There's a Y1 and Y2. Okay, so that's all pretty standard from what we've been doing. That's from the distance formula, slope, writing the equation of a line. We're pretty used to gathering and utilizing X1, X2, Y1, Y2. Now we've got a couple new friends. And our new friends are, both of them have A and B. Okay. A and B are simply acquired from the ratio. So A to B. So the ratio we just used when we were dividing our segments individually by hand, that ratio is what is going to be A and B. Are we ready to party?
Yeah.
Woo! Party hardy, bro. Let's get after it. So find the coordinates of point P that lies along the directed segment LM from L to M. So L is 3, 4. M is 6, 10. Remember, our order matters. So now we have to make sure we know we're going from which point to which point. Okay? So this is our x1, y1 because that's our first point. x2, y2 because that's our second point. And then we're going to partition our segments into a ratio of 2 to 1. So if you remember what I just told y'all, our ratio is A:B. So for this sake, A equals 2 and B equals 1. So if you go back to what we were talking about, we identified all of the players from our original formula. We've got them all. We are ready to put them to action.
Yeah, we are.
Yes. Yes, Queen. Rocket. Indubitably. All right. So our formula in all of its glory is, I'm going to bring my little button down here. So x comma x1 plus a over a plus b times x2 minus x1 comma. Oh no, don't go dark. We're going on an adventure. Comma y1 plus a over a plus b multiplied by y2 minus y1. Man, that is a mouthful. We have just got to take our time. Okay, we've got to take our time and make sure we're substituting the right people. Okay, so this is not something we want to rush. So x1 is 3 plus 2 divided by 2 plus 1 multiplied by 6 minus 3. Is that right? X1 is 3, A is 2, B is 1, X2 is 6. By the 3? No, because that first parenthesis is just the point itself. Holy smokes. So then we get y1, which is 4, plus the same ratio, 2 over 2 plus 1. And then now we have 10 minus 4. And then we close that parenthesis off. So it's imperative we follow PEMDAS. Okay, before we start trying to combine and do all that fun stuff, let's make sure we take people down to what they're supposed to be. All right, so that 3, he's just going to have to hold off. 2 over 2 plus 1 becomes 2/3. And then 6 minus 3 is 3. Same thing on the right. That 4 is just going to have to hold on for a second. 2 over 3 times 6. Now, what comes first? The addition of 3 and the fraction, or the multiplication of the fraction? Multiplication. So 2/3 times 3 is 2. And remember, if we can't just see that, come off to the side, multiply fractions straight across. 6 over 3, which reduces to 2. Same thing on the right. Comma, 4 plus 4. Okay, if we don't see it, 2 over 3 times 6. Multiply straight across. 12 over 3 is 4. And then now we have our first grade addition. 3 plus 2 is 5. 4 plus 4 is
8.
8. Ta-dance. That's it.
Because that's what I do.
That's what you got?
That's what I got.
It's fantastic.
Let's go.
That's what's supposed to happen. All right, let's do one more for the sake of our viewers at home. I'm just going to go straight down to number 9. So given our points, x is -5, 4, y is 7, -4. Find the coordinates of P on the line segment XY. So our X is our first point, and our Y is our second point. So X is X1, Y1, Y is X2, Y2. And then our ratio is a ratio of A to B. So it is A equals 1, B equals 3. Okay?
Yep.
So we're going back to get this awesome formula. We'll cheat a little bit, little copy and paste action. Okay. So that's the formula we're going to use to partition our segment. Again, you don't have to memorize that. I don't even have that one memorized. It is a behemoth. Behemoth. So we're substituting -5 plus 1/1 plus 3 is 7 minus -5. And then do the same thing on the right side. 7 plus 1/1 plus 3, and then -4. Oh, y'all didn't catch. So it's, thank you for catching right there. That's a good catch, guys. So it's 4 plus, good catch. I like it. Good catch. Excelente. Our PEMDAS, before we can really combine, remember a minus minus becomes a plus because of multiplication. That -5 is going to have to hang on for a little while. We got 1/4 times 12. And then 1/4 times -8.
Oh,
Your calculator will do this for you. Just to make sure if you put it into your calculator, you put parentheses 1/4 or use your fraction button. You get -5 plus 3, 4 plus -2, and our final point is -2, 2. That's going to finish us up for partitioning a segment. You won't see a whole lot of these on your assessment, but they will be there.